In this review video, we're going to be discussing graphing. So before attempting this lesson, you have to be comfortable with the coordinate plane, and you should be comfortable with function notation. All right, that's already been covered in the review videos, so you should already be comfortable with function notation. Graph transformations, you don't need to know 100% what they are, so we'll discuss them in this video, but you know the general idea that you can move things around. All right, so why are graphs important? Graphs are really important because, especially when we're learning a new function, if we look at its graph, we're going to learn some interesting information about this function. For instance, when you graph x squared, uses parabola, which if you've been dealing with linears, your lines the whole time, it might be really interesting to see this kind of curve that doesn't go off in one direction. And then you learn some things about quadratics, like they have this low point, which is the vertex. All right, so we can learn information from these graphs because it's a nice visual way of visualizing what's happening with our function. All right, so we learned a lot of different methods for graphing throughout the semester. The first strategy is just finding points. If we find a bunch of points on our graph, and we just find these points, eventually you can kind of see the picture. If we find enough points, the picture comes together and you can find the graph of your function. So you can always just do this. Any function you're doing, all the way up to whatever your highest level math course is, if you ever need to graph a function, you can always just find points. And the way we find points is we can pick any x value. Right? We pick the x value and we plug that into our function. Our function is going to do something to that x value and give out a y value. So we put in this x value, our function gives us out a y value, and this gives us a point on the graph. And if we do this enough times, we kind of fill in all the gaps and we know what our graph looks like. All right, so this is always the method you can do. All right, everything else is pretty much a shortcut from this method. All right, strategy 2 was specifically to linear equations. Again, linear just means there's kind of an x, not an x squared, not a square root. If it's just kind of an x in your equation, it's linear. Right? And if it looks like y equals mx plus b, b is the y-intercept, so that's where it hits the y-axis. And m is the slope, and that is rise over run. So it's how much you're going up and down over how much you're going left and right. All right, so it's a shortcut method for graphing lines. And it's really quick. You just graph the y-intercept, graph another point, you're done. All right, the third strategy. Third strategy we learned is using a parent function and then moving it around to get the graph of your new function. We didn't word it this way when we originally learned it, but this is kind of what we're doing. So if we know what the graph of the square root of x looks like, we can graph this function by just knowing what happens when I do these numbers. All right, what do these numbers do? And these are the graph transformations. All right, so we'll talk about these we do in examples. All right, so to work with transformations, you need to know what the basic parent functions look like. And right now we just have two parent functions. We have f of x equals x squared and g of x equals the square root of x. So x squared problem or a square root problem, we can graph using transformations. All right, once you have your parent functions down, you just need to know your graph is going to move some left and right, some up and down, and it might actually flip upside down. All right, so first we need to know, what do the parent functions look like? So let's just say you forgot what x squared looks like, just so we can review strategy 1. Strategy 1 is we pick some x values, we plug those into our function, which our function just says take that number and square it, and that's going to give us a bunch of y values. So putting all that together, negative 2, 4 is on my graph. Negative 1, 1 is on my graph. 0, 0. 1, 1, and 2, 4. Right. So these are the points. I could do some more graphs. I could put in 3 and get 9. I could put in like 1/2 and get 1/4. If you do more of this, you're going to see your graph is this parabola or x squared. So these 5 points are pretty much what I'm going to use for my parent function of x squared. If I can get these 5 points right, I kind of know how to draw my parabola from there. Square root of x is similar. So if the square root of x we saw in our domain value, we can't put in any negative numbers. So the first number that makes sense to put in is 0, and then 1 and 4. Right. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. You could put in 2 and 3, you're just going to get numbers that aren't super nice. You have to use a calculator. So these are the ones that end up being nice. All right, so 0, 0, 1, 1, 4, 2. And we get this kind of half curve going up like that. That's our square root parent function. And if I'm graphing a square root function, there's kind of 3 points I want to get right, and those give me the general idea of my square root function. All right, so now we're going to look at examples. I look at this example, I don't see an x squared, so it's not an x squared graph. I don't see a square root, so it's not a square root graph. So chances are it's linear, and it is linear because I just had this x by itself. And this is in the form y equals mx plus b. So this b value is my y-intercept at -1. And this 1/3 is my slope, which is rise over run. So I'm going to rise 1, which means go up 1. I'm going to run 3, which means go right 3. And that gives me the next point on my graph. And because I know this is linear, all right, so it's important you know it's linear because there's just that x. If it's linear, I just draw a line that connects those points. Just make sure it goes off in both directions forever. All right, so if you know that shortcut, you can always do that. You also could just plug in some x values, get some y values. Right, I'm just not going to do that in the video because it's just longer. So the shortcut methods are the way we want to kind of practice doing these. All right, here we're going to have x minus 2 squared minus 3. So you can see the kind of x squared. All right, so x squared is our parent function. So we're thinking about what does x squared look like? It looks like this parabola. We have those 5 points we know. Except for now we have this minus 2 and this minus 3. All right, so things inside with the x, so inside with the x, move our graph left and right. Things outside, like this minus 3, move our graph up and down. So my original parent function, let me draw the original parent function, which we saw in that earlier slide. Just keep it all in red. Is going to move right 2. All right, so this is where the inside part's a little bit different. It's kind of the opposite of what you see. So I'm going to move right 2 and then down 3. All right, and that gives me a new kind of vertex of my parabola. And all the other points, those nice points, those kind of 5 points I have, are all going to do the same thing. So right 2, down 3 gives me a point there. Right 2, down 3 gives me a point there. Right 2, down 1, 2, 3 gives me a point there. Right 2, down 3 gives me a point there. So now I have this nice parabola that's just shifted right and down. Right. Again, this is explained a little bit more in depth in the actual lesson where you first learned it. But now as a review, hopefully you're just kind of remembering, all right, inside moves left and right, and it's kind of weird because I see a minus sign, but it actually moves me to the right. Outside moves me up and down. It's a little bit nicer because the minus sign actually moves you down. Here we have 4x minus 2y equals 6. Again, I don't see an x squared. I don't see a square root, so this is going to be linear because I just kind of have a single x. But it's not in y equals mx plus b. So my first goal, well, you could always graph it by, again, plugging in values. But if we want to use our shortcut of y equals mx plus b, we need to get y equals. So I'm going to do is subtract 4x from both sides. And normally we would write like 6 minus 4x, but if we want the x in front of the number for y equals mx plus b, and then divide by -2. And here's the most common mistakes. People just kind of do this, but you need to divide everything by -2. All right, whenever you divide an equation, divide everything by that number. It's going to give me positive y. -4 over -2 is positive 2. 6 over -2 is -3. All right, so now I've transferred this function into y equals mx plus b, and I graph it the same as example 1. So -3 is my y-intercept. 2 is 2 over 1. So it's rise 2, run 1. And now I have my line. All right, so this one is just, again, recognize it's not one of those parent functions, not a parabola or a square root function. So solve it for y, making sure, again, this is the common mistake here, right, not dividing that by -2 as well. And you just do y equals mx plus b. All right, right away, in this one, I see the square root, so I know I'm going to kind of need my parent function, my square root function. All right, but in this case, there's 3 different things happening. So first, just like that x squared example, there's a +1 on the inside with the x. That's going to move me left 1. All right, the plus moves me left. On the outside, there's a +4. That's going to be up 4. There's also this minus sign in the front. And minus signs just kind of flip things up and down. So we'll see what that does in a second. But first, let's just start off this first point. It's going to go left 1 and up 4. So now it's going to be Actually, that's F1, F4, it's going to be there. Now, if you look at my original square root function, everything kind of goes up to the right. But this negative flips everything, so now it's going to go down to the right. All right, so now this point's going to go, instead of going, it's going to go there. Oops. And this point, 1, 2, 3, 4, 1, 2, is going to go there. All right, so now I have this kind of upside down square root function. All right, the way you can do this is you can move it kind of without the negative first. It's going to be there, and then you kind of flip it over that line where you started out. Right? But just knowing this negative sign kind of flips things over for your graph. All right, so if I had a quadratic that goes like that, the final answer is going to go upside down. I have a square root, the final answer is going to go upside down. All right, so for all these review videos, again, don't have to do an individual skill check, but you should be doing all the practice problems to really make sure you understand. All right, make sure you're graphing all of them. They all have their own little quirks, and they kind of build on each other. Just make sure you're looking at all the problems and practicing them. And again, if you kind of are able to get through all the review and kind of complete the fall exam with a really high score, then you can move on to the challenge problems. They're going to push you a little bit farther to make sure you really understand all that we've covered.